Hello, these notes are going to be over the properties of limits. So going through these properties, a lot of these properties should look familiar based off of pre-cal. So going through each one, we have the constant rule. The constant rule says the limit as x approaches c of k is equal to k. So pretty much if we have a limit of a number, it's going to equal that number. Identity rule says the limit as x approaches c of x is equal to c. Notice that we don't have a function here. Okay, we don't see like f of x, right? We just see that this x value is repeated here. So anytime we see that and we have the limit of that, we call that the identity rule because the answer is just going to be c, whatever x was approaching. Okay, the next one is the coefficient rule. All this is saying is that if we have a coefficient in front of f of x, for example, 4x squared, instead of multiplying that coefficient into the function, then taking the limit, we can just take this out and put it in front of the limit. So this would go in front here, just like it's seen here. Sum or difference rule. All this is stating is that instead of adding or subtracting the functions first, then taking the limit, we can give the limit to each function, then add or subtract. And you'll notice that this is similar for the product rule and for the quotient rule. And the only big difference in the quotient rule is since we're dividing here, we have to make sure that this limit in the denominator never equals 0. Okay, then we'll end up with something that's undefined. Then we have the power rule, and the power rule states that if we have a function being raised to a certain power, let's say squared, okay, instead of squaring the function, which could be tedious and take a lot of time, we can just take the limit of the function and then square the whole thing. Okay. Same with the root rule. Okay, instead of taking the, let's for example, square root of the function, then taking the limit, we can just take the limit and then take the square root of whatever that numerical value was for the limit. And then lastly, we have the composite function rule. So think composition of functions, a function within another function. When you see this, you just need to remember that you are only taking the limit of the inside function. That's what it looks like here, the limit of the inside function. Once you get some value, let's call it a, then you are plugging in that value a into the other function. So in this case, f. And here, you're not doing the limit or seeing what's approaching, anything like that. You're going to find f of a on the function, whether that's numerically or graphically, and see if that value exists as a point or not. So let's look at some examples. Example 1. Wants us to look at all of these and then first use the properties to expand these properly and then try to find the limits. If the limit does not exist, we have to explain why. So starting with A, we have the sum rule. So I can rewrite this as the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. Okay. Once I do that, now I'm just focusing on those limits separately for f and g. So first looking at f. Okay. So f is looking for as it approaches 3 from the right. So here's 3. And to make it easier on myself, I'm just going to highlight where the 3 is all the way up the y-axis. So going down to the positives and the negatives. And then I'm going to draw me a small interval, okay, around that 3. And I do that because since I'm only coming from the right side, I only need to focus on this side within that small interval. Well, this side, since it's coming from the right, as it's getting closer and closer and closer to that pink line, which is 3, I notice that it's slowly approaching the value 6 on the y-axis, okay? And many of you might think, well, there's an open dot there, so the limit can't exist because we can't have a point at that dot. Well, that's only true if we were trying to find, for example, f of 3. Well, f of 3 does not exist because there is an open circle. But anytime we're thinking about limits, that doesn't matter. So kind of dump that information, put it in the back of your mind. Limits are what are we approaching, okay? So maybe as we're getting closer and closer to 3, it's not going to be exactly 6, but maybe it is 5.99. Okay, so again, as we're looking at that right side, we're seeing what it's approaching. So it could be like 5.999 and not necessarily 6, but we don't want to write that 5.99. We're just going to say that it's slowly approaching 6. So I would go over here and I would write 6. Now I need to do the same thing for the g of x function. So going over here, g of x, again, I'm looking at 3. Okay, so here's 3. And then I'm going to draw that line and then my small boundary around it. Okay, and I'm only looking at the right side. Well, notice I have two functions approaching 3. I have one from the left side and then one from the right side, but I only care about that right side. So as this right side is slowly approaching my pink line, or 3, I notice that it's slowly going to approach the value 8 on the y-axis. So then this one is going to be 8. So 6 plus 8 gives us 14. Okay. And we're going to do the same thing for each of these. So I'm not going to go back and forth to the graphs. I'm kind of just going to explain the properties. And if you need more assistance looking at the graphs, I highly suggest you come to tutoring so I can help you out one-on-one. But for these, we're just practicing, okay, can you use the properties and put this in expanded formation? So here we have the coefficient property and the difference property. So I can write this as 3 limit as x approaches 5 of f of x minus 2 limit x approaches 5 of g of x. Okay. And then if I was to find the limit as x approaches 5 on f of x and g of x, I would find that for f of x it's 2, so this is 3 times 2, minus 2 times, for g of x would be 4, which gives me 6 minus 8, which is negative 2. C, this is again a difference of two functions. So I have the limit as x approaches negative 5 from the left of f of x minus the limit as x approaches negative 5 from the left of g of x. So looking at the f of x, I get the value 3. So this is 3 minus, and then for g of x, I get 4. So 3 minus 4 is negative 1. For D, I see that not only do I have the quotient property, I also have the coefficient of that 3 in the numerator. So I would rewrite this as 3 limit as x approaches negative 7 of f of x divided by the limit as x approaches negative 7 of g of x. And the big thing here is I need to make sure that this g of x function, okay, does not equal 0. So if I'm checking each one, I get 5 for the limit as x approaches negative 7 of f of x. So this is 3 times 5. And then for g of x, I get 3. So this is 15 divided by 3, which is 5. Okay. Now I'm going to look at E, and then I'm going to skip down and look at H. Okay, because E and H are both special cases where when we do all the math here, look at both the functions, we're going to find out that these limits do not exist. So first I'm going to write this out. So this is going to be 4 bracket limit as x approaches 3 of f of x times the limit as x approaches 3 of g of x. Okay. The limit for f of x is going to be 6. So I have 4 bracket 6 times, and then the limit for g of x, I'm going to notice does not exist. Okay, so since I have any part of this that does not exist, that means this entire limit cannot happen. And so the entire limit does not exist because the function g of x is not continuous at that point. Okay, so looking at just the g of x portion on the graph, okay, I'm going to go ahead and erase this so I can look at x approaches positive 3 from the left and the right. So here is my small interval, and I have to check, since it doesn't give us direction, if I get the same limit coming from the left side versus coming from the right side. So coming from the left side, notice that this is the function coming from the left. As it's getting closer and closer to that pink line, or 3, I notice that it's going to approach 1 on the y-axis. So this one is 1. But then if I look on the right side, as this is getting closer and closer to that pink line, or the 3, I notice that I am going to approach 8 on the y-axis. So since 1 is not equal to 8, that tells me the limit does not exist approaching 3 from both sides for g of x. So that's how I got this does not exist. Okay. I'm going to look and jump to h real quick so we can see something similar. So here, this is the limit as x approaches negative 3 of f of x, plus the limit as x approaches negative 3 of g of x. Again, there's no direction here, so they have to be approaching the same value from left and right. Well, when I solve this, I get negative 6 plus, and then for the g of x portion, I get does not exist. So again, if I end up with does not exist anywhere, the whole thing does not exist. Now looking at f, this is the power rule. So I can actually do the limit as x approaches negative 3 of f of x, and instead of just raising the function to the power of 2, I can raise the entire limit to the power of 2. So when I solve that, I get negative 6 squared, which is 36. Okay, then g. Here I have the root property. Notice, however, it looks like that I will have a coefficient here in front of g of x. So because of that square root, I can't just simply take out the 8. If I'm going to do that, I need to also take out the square root of 8. Well, that sounds like a lot of work, so I'm just going to leave it there. So writing this would be the limit as x approaches 4 of 8 g of x, and then we take the square root of the entire thing. Well, the limit as it approached g of x is 5, so this is a square root of 8 times 5, which is equal to the square root of 40. However, I have to simplify this since it's a radical, and I do that by doing the prime factor tree. And if you recall from Algebra 1, the prime factor tree is where we divide into this radical by prime numbers, so 2, 3, 5, 7, etc. And we stop doing the tree as soon as we stop at a prime number. So 2 goes into 40 20 times, 2 goes into 20 10 times, 2 goes into 10 5 times, and I stop because 5 is a prime number. I circle my pairs of 2s. These are going to come out to the outside, and whatever I have left over out of my prime numbers, I multiply them. So 2 times 5 is 10, and so my answer is 2 square roots of 10. Okay, now looking at J. So it looks like I just have the quotient rule here. So I have the limit as x approaches 6 of f of x over the limit as x approaches 6 of g of x. And just recall that this part here cannot equal 0. Well, when I take the limit of f of x, I find that it's 0, which is okay. The numerator is allowed to be 0. Divided by, when I take the limit of g of x, I get 5, so my answer is 0. And then lastly, K. K, I have the composition of functions. So I have f of g of x. And remember, when I have that, that just means I take the limit of the inside function and then plug in whatever my answer is into f. So this is going to become f of the limit as x approaches -2 of g of x. And when I solve that, the limit of g of x is -3, so this is f of -3. And here I'm just finding the point. When x is -3, what is y? Well, when you look back up to the graph, you get the answer of -6. Okay. Now let's look at example 2. In example 2, we see that it gives us 3 different limits and the answers for each one. So the limit of f of x, g of x, and h of x. And it wants us to do is simplify each of these problems using the properties of the limits and then plug in the numbers that it gives us. So here we're not necessarily solving anything limit-wise. We're just seeing if we can remember the properties and then plug in the numbers already given. Okay. So for this one is using the root property, the coefficient property, and the difference property. So this is going to be written as the square root of 3 limit x approaches c of h of x minus 2 limit x approaches c of g of x. Well, I know that g of x is -2 and h of x is 4. So this is the square root of 3 times 4 minus 2 times -2, which is the square root of 16, which is 4. So that's my answer. For part B, I have the product rule and the coefficient rule. So this would be the limit of f of x as x approaches c times 5 times the limit as x approaches c of g of x. Okay, again, I know that f of x is 3, so this is 3 times 5, and the limit of g of x is -2. So 3 times 5 times -2 gives me -30. Okay. For C, I have several properties here, one of them being the constant function property. And so I have the limit of x approaches c of 7, okay, let's see, minus the limit as x approaches c of g of x, and it looks like the whole thing is being squared. Well, based off of the property of the constant functions, since I have the limit of just a number here, I know my answer is going to be that number. So this is 7 minus, and then I know that the limit of g of x is -2, so -2 squared. So this is 9 squared, which is 81. Okay. Then I have D, so using my properties, I'm going to give the limit to each part. So I have 2 times the limit as x approaches c of f of x plus 3 times the limit as x approaches c of h of x, all divided by the limit x approaches c of h of x minus the limit as x approaches c of g of x. Okay. And I see that I get 2 times 3 plus 3 times 4, plugging in my values, all divided by 4 minus a -2, and that gives me 18/6, which is 3. Okay, part E. It looks like here I have the limit as x approaches c of h of x, okay, times, and it looks like I have to put this separately in brackets because it says f of x plus 6. So this is the limit as x approaches c of f of x plus the limit as x approaches c of 6. So then I know h of x is 4, so this is 4, okay, times f of x is 3 plus 6, so this gives me 4 times 9, which is 36. And then last one for this example F, okay, it looks like here that we have the square, so we have the power, we have a constant, we have quotient, we have difference, we have a mix of everything here. So this is going to be the limit as x approaches c of f of x squared divided by the limit as x approaches c of 4 minus the limit as x approaches c of g of x, which is going to equal 3 squared over 4 minus a negative 2, which gives me 9 divided by 6, which is 3 halves as my answer. Okay, now let's look at the next example. It says, given the limit as x approaches c of f of x is equal to 8, okay, and the limit of g of x is equal to negative 4, find the following. Okay, so it's another big one here. And notice there's so much going on. So first what I'm going to do is I'm just going to use all my properties, okay? And I am going to take the limit of each part. So I have 2 limit as x approaches c of f of x times the limit as x approaches c of g of x, okay, minus the limit of x approaches c of f of x, this entire part raised to the 1/3 since it's the cube root, plus 2 times the limit as x approaches c of g of x, and then this whole thing squared. Okay, so this gives me 2 times 8, okay, times negative 4, so I'm plugging in for f of x and g of x, minus 8 raised to the 1/3 power plus 2 times negative 4 squared. So this is negative 64 minus 2, because the cube root of 8 is 2, plus 32, and this is equal to negative 34. So if you can do problems like example 3, like you're on top of it, you know what you're doing. This is included almost every single property you could think of in here. So if you know your properties and you can plug in and do your math, you're good to go. So example 4 is looking at composition functions. So remember, with composition functions, we are taking the limit of the inside function and then plugging that into f. So this is the limit as x approaches 2 of g of x, which is negative 2x. Okay, what I'm going to do is just plug in this 2 for x. So that means the limit is negative 2 times 2, which is negative 4. And then I'm going to just solve f of negative 4 by plugging negative 4 into all of my x values. So negative 4 cubed minus negative 4 squared plus 4 times negative 4 minus 1. And when I plug that all in, and I highly recommend you just plug it all into Desmos to get your answer, I get f of negative 4 is equal to negative 97, and that's my answer. Okay, part B is now doing the opposite. Now, instead of f of g of x, this is g of f of x. So we're finding the limit as x approaches 2 of f of x first. So the limit as x approaches 2 of f of x is the same as writing the limit as x approaches 2 of x cubed minus x squared plus 4x minus 1. So I'm just going to plug in 2. So this is equal to 2 cubed minus 2 squared plus 4 times 2 minus 1, okay, which equals 11. Then I'm going to plug 11 in for g. So g of 11 is equal to negative 2 times 11, which is negative 22. So that means g of 11 equals negative 22, and that's my answer. Okay, last example. It says, use the graphs of f of x and g of x below to find the limits. So we're still doing those composition of functions, but now we're looking at graphs. So we have the limit of x approaches 3 of g of x. That's what we're looking for first. So I'm looking at g of x, and I'm looking for 3. So this is 3. Okay, so if I'm looking at either side of 3, I have to make sure that on both the left and the right, we're approaching the same value. So here's the left, here's the right. They're both approaching 1. So then I write f of 1 is equal to, and then I find 1, which is right here, and that corresponds to -2. So my answer is -2. Okay, now I do the same thing, but now I'm looking at the limit as x approaches -1 of f of x. So I'm going to find -1, which is right here, and draw a small boundary around that. And I need to make sure that from both sides, my function as it's approaching -1 is going to the same y value. So that's this side here and this side here. Notice how this is continuous. So since it's continuous, we know it's both going to approach the same value, and that is -6. So I find g of -6. I go over to my g function, and notice that this function g is going by 2, so -6 is actually right here, okay? And if I look at this, I can see, well, it's kind of going off the graph. So what I have to do here is I can't say, okay, well, I'm going to say it going this way and just give an estimate. I can actually just look at the slope of this line here and try to create a function that would match that. So what I am essentially doing is finding y equals mx plus b. Okay, so if I was to continue this up, it looks like my y-intercept would be 5, and then my slope using 2 points would be up to right 1. So it looks like this would be y equals 2x plus 5. I want to find g of -6, so this is y is equal to 2 times -6 plus 5, which means y is equal to -7. So g of -6 is equal to -7, and that would be my answer. So we had to do a little bit of extra steps on that one. And then part C, we're finding the limit as x approaches 1 of g of x. So I'm going to go to g of x, and I'm going to erase all this here. And I'm looking as x approaches 1. Okay, so 1 is right here. And I do a small interval around that. And I need to check that on both sides, left and right, they're both approaching the same value. So on the left, that's this function. I notice that this is getting closer to the pink line, that this is actually approaching -1. But on this side, the right, as this one's getting closer to the pink line, this one's actually approaching -3. Well, since -1 and -3 are not the same number, then the limit of g of x does not exist. Okay? So what we would do here is we would say, okay, well, we check the limit as x approaches 1 from the positive side of g of x, and then the limit as x approaches 1 from the negative side of g of x. We found that from the positive side, the right side, this is equal to -3. And then from this side, we see that this is equal to -1. Okay. So what this tells us is that neither of these are existing at that value. So we have the limit right here, since -3 is not equal to -1, it does not exist. Okay. So what we would need to do then is say, okay, well, can we really find the value from each -3 and -1? Okay. And we would have to see if we could find the limit now for each of these, since we got 2 different values. Okay. So what that means is what we're going to have to do now is we have to find the limit as x approaches -3 Okay. And for f of x, and see if it is equal to the limit as x approaches -1 of f of x. So let's go ahead and check that out. So f of x, let me erase this. Okay, so we're looking at -1 and -3. Okay. So we would look at the small boundary between each one. Okay, and we'll notice that when we are looking at -1 from both sides, okay, so that's this side and this side, we get -6. Okay, and then if we're looking at -3 from this side and this side, it's also approaching -6. So even though we got a does not exist for a composition function, that did not mean that the entire thing was wrong. That just means we then check for the answers that we got, and we see if the limits of those answers of f of x is going to give us the same value, and they did, which was -6. So that is the answer. Okay, I know, kind of tricky. I'll go ahead and try to re-explain that a little later if anyone has any questions. Okay, and then lastly, D, we need to find the limit as x approaches -3 of f of x. And so we would go and look at that, but we actually did that over here already. So remember when we did x approaches -3, we got -6. So we could just say, well, this is g of -6. And we know g of -6 because we found it in B, so we would just say that the answer is -7.